My name is Sumant, and today I'm going to discuss on a software which is typical database management software developed for the hydropower sector. This software has basically been featured to address certain management gaps that happens in the sector. Well, the first two aspects that this software addresses are the database management, and second is the control of the time and the cost overrun. Software keeps the database on many aspects that is related to this field. The current page that you can see is project page, which displays the list of all the hydropower projects. And if you see, there are a lot of options in your left, like the cities, or states, countries, developers, districts, PDA tasks, a lot of other things. These are all the database libraries that has been kept in this system software. Second is the lookup type certain. Again, see some academic, personal, professional, and everything that can be part of the hydropower, like project category, project types, project stage, and a lot of other things have been considered for the database libraries. So I'll be discussing these things in the later part of this video. Now let's go straight to this is the list of all the hydropower projects. So if you want to go and explore any of the project, you can just type the name. Let's say you can type this lower, and any projects that has the lower within its name will be displayed here. And let's say if you want to go with number 5, uh, you can click there and it will redirect you to this page. So this is basically the project details page, where you can see these are one-to-one relationship fields. There are some coordinates and basic river category, stage and install capacity type of things. So these things we already have seen, or that has been separately included in another module. So this module I'll be basically focusing on the main work that has been done through the software. The first, let's go there are you can see these are one to many or many to many relationship fields, where one project can have many of these fields. So these things have been included in this part of this page. And now let's go to the project schedules. Click it here and you'll get through this page, and this is a page which has already been generated by the software. So what does it look like if you do not have any calculations already made? So what do user have to enter within this page? So before we come to that part, I'll just show you what are the things that has been included in this list. So if we have the work activity basically refers to any of the work that is basically happening in the construction part of the project, or maybe the construction schedule, you can say, or the entire project life cycle can be included in this. So how record gets added in this page? So you simply click this add generic record, and here you'll see this work activity. You can select anything. SA will give descender or settling basin. If you just write a all the options that is available within these names, and the uh, activity that you want to add, you can just select it. And let's say you have selected some of the activity, then you enter the estimated start date, the estimated end date for that activity, and if the activity date activity has already been performed, then actual start date, actual end date can be entered here. But if any new project comes and it wants some analysis from this software, then definitely they have estimated start and end date, because that is the first part anybody uh, comes with. And then they do not have the actual start date and actual end date. This is something that the software is about to give us. So how does it give us? So there are certain rules and uh, algorithm that has been set here that produces this suggested started and suggested ended. Let's see how does that go. So once the user inputs these estimated start and end date database, then let's say you have entered let's say descended settling basin database that you have entered, and it's estimated started and estimated end date you you have entered, you have nothing else here. So in addition to that, user also have to enter uh, which previous activities does this activity is linked with, or its dependent activities. So you click on that work activity, and it will give you a couple of uh, another couple of relationship tables, where the first is overrun region. So uh, for some projects already have certain overruns in this uh, activity, then they will write the reason, what were the possible reason for the overrun. Let's say if there is any reason for let's manpower issue, these things can be added here. So my project is new and I do not have actually any overrun, because this activity has not yet been completed, so I cannot have anything in overrun. So what are the dependent activities for this activity? So mobilization is the dependent activity for this particular descender basin activity. So we'll go back a couple of times. You can see, press this or control F, you can go here, and within this you can. Now, against every work activity, there is one equation associated with it. This equation has certain coefficient of correlation and estimated duration that we get from the user. Since user inputs the estimated start and ended, we get the duration. Then the software generates the suggested duration from the equation. There are a couple of durations that has been generated from the software. Now, once the project gets completed, then actual duration, means actual start and end date, can be entered. This actual start and end date can be entered from site reporting or whatever method. You can edit here, and let's say you can edit here and just mention those dates as well. So there you can go and compare these things. So how does this data be helpful for the site management team or site engineers, site managers? How is that useful? Since the estimated duration is 1352, actual duration is 1607. The software has provided you a couple of suggestions on on the durations. What could it be? So based on this database has been proposed, and what is the logic behind this? Also right away. So behind the concept and calculations of the suggested duration, there are two suggested duration. You can see one suggested duration is a normal suggested duration, another suggested duration is the suggested duration that has been derived from the equation part. So the first part, let's talk about the suggested duration. How does it come? The concept behind this suggested duration is, first of all, the PERT analysis. PERT analysis is basically the program evaluation and review technique, where it takes into consideration the extreme database and the central database, which we can say the most optimistic time, the most probable time, and the most pessimistic time, where more weightage is given to the most probable time. Here in this software, the probable time is given to something which is called the estimated duration. Now, if you say the most optimistic time is also taken from the database, and it is the least of the delays or most of the delays that you can say. So, if you take 100 database, there will be one data which is at the last and one which is at the top. So, this T and TB are one of them. The second second thing that has been taken into consideration is the general statistical method, which is you just provide the mean of all the database that you have, selected database, or you can say you obtain the mean from there, and from there you can predict the average delay. So calculated duration would be the average value of what has been in the history of the software, which means the software or database history. Now what you do is you obtain expected duration from here, and again another expected duration is calculated from here. From these two averages, mu and mu prime, you can calculate the suggested duration. Here we have said it mu bar, and this is the average of those. Similarly, variances in both the cases have also been calculated here by this formula and here from this formula. Then the average of those two has been taken as the suggested variance. Now from here you will get the suggested duration and suggested variance. And variance is where variance, you can say standard deviation has been also in a part of the variance. If you square root this, then you'll get the variance. Now let's move ahead and see the second part, which is the suggested duration from the equation. Suggested duration from the equation is basically generated from this concept, calculation of equation for work and cost overrun. This is the generally the straight line regression equation, y is equals to mx plus c. And if we have n number of database, we get m and c from these formulas. And this is the general statistical formula again. Now the coefficient of correlation is again calculated. How well these data are correlated, this will give you the correlation value. And from here the suggested duration can be calculated from estimated duration plus y, where y is the delay, which is equals to mx plus c. X is nothing but the estimated duration. So these two coefficients are used to calculate the suggested duration derived from equation. Thus for every activity we'll calculate, the equation has been calculated, and on the basis of this equation you get the suggested duration for the equation. Now suggested duration, again another, as we have earlier suggested, will has also been proposed from here, and on the basis of these two suggested durations the timeline for the entire project has been calculated. I mean, if all the activity suggested duration is there in the chart, and you also have the estimated duration, you will the software will find you the suggested start date and suggested end date, equation suggested start and end date. These are the things that the software generates. Now the further analysis can be seen from here. This detail page basically gives information on all the real and dummy activities. So every activity, their start date, their end date, their free floats, total floats, and duration as well. So duration is already associated with the activity, while the software calculates the updated start date and updated end date of this. And updated start date and end date is calculated here. So updated start date is based on this algorithm. This is a flow chart and it compares all the dependent activities, and due to the lag that is present between the two activities, this concept had been introduced so that the start date will be updated. Now so here you can see there are many activities that starts with the same name. So one of them has to be real activity and others might be their dummy activities, because in order to create CPM diagram, these things taken into consideration in this software. Now another is the paths. So once all these nodes and all these activity node links are created, the path can be easily calculated from the software. Software calculates the path. Some of the path are non-critical and some of the path are critical. So a total of for this project I would say a total of 30 path has been created, out of which some are equated timeline, some are suggested, while some are estimated. So all these other path information is given here. If you see, if you go to the information page of this path, then you'll see these activities are included in this path, but this path is not a, is this a critical path? No, this path is not a critical. So the float that has been shown in the earlier pages, it gives you the total delay that you can make in an activity, while the path definitions will give you whether your path is critical or not. So in here we'll see 1 2 3 4 5 critical paths, out of which 3 belong to the estimated timeline, while only one belongs to equated and suggested timeline. All these paths are created from by the software. Now if you go to the path here, information on this path, you will see these are the activities which are critical. If you sort the order out, the first start activity, purposes agreement, and similarly mobilization, headworks, trial, commercial operation, and the uh, total completion days is 2,156 days for this project. While if you go back and go to the estimated timeline here, let's see what happens, and it gives you 1907, which is the duration, total duration of the project, and same activities are in critical. So you see in total the suggested timeline shows you certain delay. So in total of this much delay is shown from this software. Now delay in which activity, so which activity will start when and when will that end, that is all mentioned in the project schedule. So it is as simple as that. Here in this, all the timeline is provided here. So this is very important when you are at site and have to analyze the project at any time, so they can parallelly check the timelines and they can take decisions accordingly. Now once we are through the project schedules and all the things associated with the activities, work activities, now let's go to the project cost. It is very similar to what we have done for the work activities. It is similar has been done here in the project cost. Every cost has been linked with one equation, and the estimated cost can be is generally inputted from the users. Then there are a couple of suggestions on the cost that is generated from the software based on the same concept, same equation, and actual cost. This is something what is entered after the project or this cost activity gets completed. Again, this works on the principle that uh, the more data you have, the better results you'll get. So in a few years' time, when this software will be fed with hundreds of database, the result will come very close to what people actually expect during the construction. If you want to go inside any cost, hey, then you'll find one tab where the reason for this delay can be added here. Like say the let's say sudden breakdown of machines, broke down during the work. You can submit it, and there are all the other reasons you can also mention for this cost head. See, here is the cost head, here are the other information of the project. So these things will be later helpful for the new project, so they can learn from the experience of these activities. Now let's move towards the validity of any calculations or any assumptions or the result that is provided from the software. How reliable or how can you validate these things? So basically, you can validate one activity equation on the basis of the experience only, because these things do not follow a certain trend line. So all we can do is we can go to the, let's say, work activities. This is a database that has, and here we have the equation for everything. uh, you can see the correlation coefficients. Some of them have good correlation coefficients, while let's go to the headworks again. Any of the activities you can choose to go. So if you go inside the project schedules of different hydropower projects is shown here, where estimated duration for this particular work activities summarized here, equated duration is here, actual duration is here. So what is the equated percentage deviation? So equations validity can be seen from here. So 100 versus 140, 292 versus 284, or you can see 253 versus 252, which is these are given in percentage. We can say if you sort the percentage out, you can see 0.49% to here. This, so let's do it. 12% to as less as 0.5%. So this is even on the basis of only 7 projects. right here that has been included this activity. It works. Now you can just say if you want to take these things into consideration or not. The user will have the right. So one important thing that I would like to mention is with every changes in database, this equation will change. This equation is not constant for any time. So if you are within the software, let's say if you are within any project, if you are within any project and your database changes, if your database changes from here, you can press this button and this will recalculate your equations, recalculate your equations, and then after that you can calculate the critical path. Once equation gets changed, then everything associated with the equation, this column will change, and the equations of the state start and ended, that will change. So this way this way everything is dynamic here. So I would again like to mention this performance of this software is totally fantastic, and it all depends on what is the extent and what is the quality of database that you integrate. So that is all for today, and for we have a lot of things to explain here, but this video is going to get very long if I take it here. Next video I'll upload the details on these things here, the database things and other things. Thank you.